Our trading bot received market data and built a perfect 1-minute candle. Now, what to do with this candle? Do we simply throw it away? Or should we remember it? Professional trading systems don't just process market data, they continuously build a history of the market. Without memory, there can be no indicators, no signals, no trading. Today, we are going to look at how to store your data. Welcome back to Building a Professional Trading Bot, a free course on designing automated trading systems, not just trading strategies. Before we continue with episode 3 and talk about storing market data, let's take a step back and look at what we've actually built so far. A well-designed automated trading system is made up of several components, each with a single responsibility. This separation becomes increasingly important as your system grows, because it makes the code easier to understand, maintain, and extend. What we've covered in the previous episodes is already enough to build one of the core subsystems of a professional trading bot, the market data engine. And that's no small achievement. It forms the foundation for everything that follows. Before a trading system can calculate indicators, generate signals, or execute orders, it first needs a reliable way of receiving, validating, and transforming market data. Hopefully, this diagram helps you see the bigger picture. Although we've shown a little Python code along the way, the goal of this course isn't to hand you ready-to-copy code. The goal is to help you understand how a professional trading system is designed. Once you understand the architecture, the programming language becomes almost a detail. Whether you build your own system in Python, C++, Java, or another language, the same design principles still apply. With this awareness of how we design our bot, component by component, let's continue. The market data engine has now done its job. It has successfully transformed raw market events into reliable time bars. But that is only half the story. The obvious question now becomes, what do we do with those bars? If we immediately throw every completed candle away, our trading system has no memory. It only knows what's happening right now. But indicators, trading signals, and pattern recognition all depend on understanding what happened before. In this episode, we'll design a component whose sole responsibility is to maintain that market history, the market data store. We'll look at how to efficiently store market data using rolling windows and deques, how to retrieve recent bars when other components need them, and why a good storage design makes the rest of your trading system both simpler and faster. So, let's get started. Imagine we're inside our market data store, and we've just received a completed 1-minute candle from the market data engine. Now what? What do we do with this candle? One candle alone is obviously not enough information to decide whether to buy or sell. How many candles we need depends entirely on the trading strategy, but one thing is certain: we need to store them. A simple moving average might require the last 20 candles. An ATR indicator may need many more. A machine learning model might need thousands of historical bars before it can recognize a pattern. In other words, your trading strategy needs memory. The first solution many programmers would probably consider is a simple Python list. We start by creating an empty list, and every time a new candle is completed, we simply append it to the end of the list. It's straightforward, easy to understand, and for many small applications, it works perfectly well. The problem is that our trading bot never stops receiving market data. Every minute, another candle is added. After one trading day, we have hundreds of candles. After a few weeks, tens of thousands. Eventually, our list just keeps growing. That means more memory is used, more data is processed, and calculations become increasingly inefficient. The question is, do we really need to remember every candle since the bot started, or do we only need to remember the most recent part of the market? Professional trading systems often store only the most recent part of the market. This is known as a rolling window. Instead of allowing our data structure to grow forever, we decide upfront how many candles we want to remember. Whenever a new candle arrives, it is added to the end. If the storage is already full, the oldest candle is quietly discarded. The size of our dataset never changes. We always keep the most relevant part of the market. So how do we build a rolling window in Python? Fortunately, Python already provides a data structure designed exactly for this purpose. It's called deque, short for a double-ended queue. A deque allows us to efficiently add new candles while automatically removing the oldest ones once we reach a predefined size. After importing deque from Python's collections module, a single line of code is all it takes to create a rolling window. This one line, self-time bars, is deque max length is 200, told Python to remember only the most recent 200 candles. From this point on, we no longer have to think about housekeeping. We simply append a new candle, like we would do with a list, and the deque quietly maintains our rolling window in the background by removing the oldest candle. Although we're using Python in this course, the idea of a rolling window isn't specific to Python. Most programming languages provide an equivalent data structure, or one can easily be implemented. Once again, we're learning a design principle rather than a particular programming language feature. We've now introduced the deque, an ideal data structure for maintaining a rolling window of market data. Now imagine starting your trading bot. It connects to the broker, subscribes to live market data, and 1 minute later, your very first candle arrives. Inside the market data store, that candle is appended to your deque. So far, so good. But now your strategy wants to calculate a 20-period simple moving average. There's just one problem. You only have one candle. Does that mean your trading bot has to wait another 19 minutes before it can even begin analyzing the market? Fortunately, no. Before a trading bot starts processing live market data, it can first request historical market data from the broker. That historical data is used to populate the market data store, giving your strategy an immediate view of the recent market before the first live candle even arrives. So let's go back to the callback function we introduced in episode 2. We called it onMarketData, and after building our 1-minute candle, we ended up with a completed bar. At that point, we deliberately left 3 dots in the code. But you can probably guess what belongs there now. As soon as a candle is completed, we hand it over to another component whose sole responsibility is storing market data. We called that component the market data store. Inside this class, we created a function named addBar, which simply stores the completed candle. Earlier in this episode, we initialized self.bars as a deque with a maximum length of 200 candles. This is where that deque comes into play. With a simple append, just like adding an item to a Python list, we add the completed candle to our rolling window. If the deque has already reached its maximum size, the oldest candle is automatically removed. No cleanup code, no bookkeeping. The deque quietly maintains our rolling window for us. In this example, we've chosen to organize our market data as 1-minute time bars. For this type of data, a rolling window implemented with a deque is an excellent choice. Of course, a trading system can process many other types of market data as well. As we'll see in later episodes, different types of information often require different data structures. The right choice always depends on the problem you're trying to solve. For now, our focus is on storing recent time bars efficiently, and for that, a deque is exactly what we need. Which naturally raises the next question: how do we actually ask the market data store for data? Once again, we'll give this responsibility to a dedicated function inside our market data store class. Here we've named it getRecentBars. It accepts a parameter called count, which tells the market data store exactly how many recent bars we want to retrieve. The implementation itself is quite straightforward. It simply returns the most recent candles from our rolling window. Notice how the rest of our trading system doesn't need to know how those candles are stored internally. It simply asks the market data store for the data it needs. In episode 4, we'll start using this function extensively. Retrieving the last 20 bars, for example, becomes as simple as bars is market data store, get recent bars 20. From that point on, our indicators no longer care where the market data comes from. They simply receive exactly the history they asked for. As we're nearing the end of this episode, you may have noticed that we've created several separate classes for what seem like fairly simple tasks. You might even be wondering, why didn't he just write self.bars append completed bar directly inside the callback? At first glance, that would certainly have worked. In fact, the code would even have been a little shorter. But the version we've built has one major advantage. Every component has one clear responsibility. The callback receives market data. The candle builder builds candles. The market data store stores candles. And later in the course, other components will retrieve those candles, calculate indicators, generate signals, and execute trades. Each component does one job and one job only. And this is perhaps the one software engineering principle I hope you take away from this course. The best trading bot is not the one with the shortest code. It's the one that is easiest to understand, easiest to test, easiest to extend, easiest to debug, and ultimately, easiest to trust with your money. That starts by designing your trading bot so that every component has one clear responsibility. And that's a wrap for episode 3. Today, we designed a dedicated market data store, giving our trading system a memory of the recent market. Along the way, we were introduced to a very useful data structure for maintaining rolling windows, the deque. More importantly, we've continued building our trading bot by giving every component one clear responsibility. In the next episode, we'll finally start putting our stored market data to work. We'll build our first indicators, discuss why indicators deserve their own processing component, and see how raw market data is transformed into meaningful information that a trading strategy can use. Thank you for watching. If you like this content, please do not forget to like and subscribe to help the channel grow.